Right, it's recording. Sorry, recording, and I'm sharing for the after hours. Right. Get your notes. Yeah. Sorry. Okay, right. Come for the recording. Well, still come for the recording. Right. Okay. Right. Can we go, please, guys? Sorry. Apologize. Big money for that. Right. Okay. Right. Oh yeah. All the differentiation. The differentiation booklet? Yes. All of it. Okay.
Exactly what is the amount, so I have to write it.
Yes. On Tuesday. All of differentiation, I will send you free work. Yeah.
Oh, wait.
Yes. Yeah. It's nothing to do with the like that. I'm not saying you can do that, but you'll be fine. You know, you got to use your brain a little bit. You can. And we're recording simple parts to listen to this, yeah? Yeah? Okay. All right. All right, let's have a look at this. Okay. So, time me 25 minutes, somebody. All right. So, by making use, right, by making use of a suitable sketch and using right endpoints of rectangles, determine the right sum approximation for the area bounded by f of x is equal to x squared plus 2 and the x-axis, for x is an element of 0. Use 4 rectangles of equal width for your approximation. Right, off you go. Okay. Just don't you worry about it. Right. No, as long as we follow it up, we can do what we want. Yes. Well, that's well, I do moderate. I moderate on portfolio files, and they see what we're giving you. So then they say it's too easy, it's too hard, and they judge it what it is. How's the fun? Okay. And I already love to have a comparison that everything you do is harder than any other thing in the world. Okay, right, okay. Right, so, okay. Let's say, all right, quiet when I'm talking to you. Okay. By making use of a suitable sketch, so we've got the curve f of x is equal to x squared plus 2, which is a parabola. Okay. Okay. But then what's the area? I'll show you what I mean by a right sum. Above right, it can also be called an upper sum. Yeah, we did something similar, but not the same one. Okay, so a right sum can also be called, please don't joke when I'm talking, an upper sum approximation. Okay, so they want a right sum approximation. Okay, between x is equal to 0 and 4. So we've got 0, 1, 2, 3, 4. I'm going to need some of this. That's smaller. Okay, 1, 2. The rectangles have to be equal with 3, 4. Okay. So we want 4 rectangles. Right? So we're looking for the area bounded by the curves and the x-axis between 0 and 4. Now, they said they must be either, okay, an upper sum approximation or a right sum approximation. They mean the same thing. That means It went this. Okay, right, I'm going to refer to yourselves. Okay, but it does seem to work. Are you all doing the cup at that moment, right? All right, okay. So we're going to go in the rectangle, we're going to take the right boundary. Okay. Right, picture. Right, okay. Sorry, recording was writing. Right. So that's 2. Okay. Yes, I know. 3, right, taking motion, take 5 minutes. Okay, nice stuff. Okay. So that's what we mean by a right sum approximation. Okay, the top boundary for the rectangle comes to the right hand side of the rectangle. Capish? Okay, so when you draw the rectangle, it says a right sum approximation. So you take the top of the rectangle as on the right side of where the right side of the rectangle hits the curve. So that's where the right side of the rectangle hits the curve. That's that right. So that's rectangle 1. Okay, you with me? So in rectangle 1, it's the right side. You with me? Rectangle 2, it's the right side. Rectangle 3, it's the right side. Rectangle 4, it's the right side. That's where the height comes from. Okay. Right. So now it says, okay, so now we're going to add up the areas of those rectangles. Okay. So, first one, what's the width of the rectangle? If there are 4 rectangles and I'm going up to 4. So your width of each is equal to 4 divided by 4, which is equal to what? How am I going to get the height of each? The heights are not going to be the same.
The height of the Y.
Then, because the total distance is 4, you're dividing 4 by 4. Of each rectangle, yeah. Okay, it's 4 divided by 4, which is what? Right. Are we happy that the width is what? The heights are not going to be the same, you agree? Tell us, please, what are the heights going to be? So this point would be what? 4 and mental length, which is that point would be 4, 18. Lovely. Mm-hmm. Daniela.
Wait, what?
Is Daniela or Danielle? It's a tricky border. Boris, what's this point going to be? Oh, sorry, what did I use? It's 3 bob. Okay. Right, so Gulash. Right. What's this one here? 3 and blessing.
11.
Okay, 3 and 11. Are you understanding how we're getting this? Rosemary, what's this point over here? And that? Yeah. Possibly the most annoying accent I've ever heard, but well done. Okay. Right, this accent over here, Grand Boss. Yes. 31 and 3. Right? Let's write all that down. Okay, so the areas is going to be, right, what's the area of the first rectangle? Area is length times breadth. So it's going to be 1 times 3, you have to fill this. The next plot. All right, the next one has a height of, at the point 26, so the height of that rectangle is 6. This one has a height of 3. This one has a height of, yeah, length times height, so 2 times 6. One times 6. Just checking if you're awake.
Reach.
Right. There really should be more violence allowed for teachers. Right. The next one will be what? 1 times. It's not focused you. Right. Now watch this, guys. It's something incredible. You can do this. Without a calculator. Yes, 3 plus 6 is 9. 9 plus 11 is 20. 20 plus 18 is? Isn't that amazing, right? So 38 units squared. You did. Right, okay. No, you didn't. Right, okay. Right. Right, on to the next question, please.
Don't want to admit that I'm making. Wait,
Because the height of this one, this is the point when x is 3, y is 3 squared plus 2, which is 11. So the height is 11. Yeah, when x is 2, the height is 6. When x is 1, height is 3 with me. And then you take area of the inside fringe.
That was a two.
Sorry, that's what you're Rosemary. Yes. No. That's the end of the lesson then. No, it's not happening. No. Okay, right, next one. What do you think your book is going to what? Right, so it is an overestimation. Right? Right. It's an overestimation. Where is the overestimation? Well, it's an overestimation because of these puppies here. Okay. So here in yellow. Okay. That is what makes it an overestimation. To say C shaded region. Yes. No, I'm not even interested. Okay. Right.
So why do you use this method?
You ask me about math, you can ask a question. Otherwise, no. The yellow area. If you have a question, and the question needs to be about math. Yes.
Why do we use this?
Because it's an estimation, and I'm trying to show what the point of this whole thing is to show you where the formula for the Riemann sum comes. And then once I've got the formula for the Riemann sum, okay, you have to understand, what you're going to have to understand is the formula for the Riemann sum, which comes from this idea. So if I go straight to the abstract concept, okay, your little brains will get fuzzy. Okay, right. Yes.
Diagram. So we just, it's not being justified on the diagram, it's saying by referring.
The yellow area. Refer to yellow area on the diagram. Right. Next question. Okay. So, how will we find the actual required area? Okay. Right. But the fundamental theorem of calculus said a Riemann sum can be linked to integration. Okay, as you've done before in stats. Okay. So, what am I looking for? How am I going to use integration to find that this is the area I'm looking for here in a nice shade of green? I'm looking for this area here. Right. So, thank you, normal person. Tell me, please. Yes? Oh. Thank you. Shows that this, our estimation as predicted, was an overestimate. Yes. Yeah.
He worked it out better.
No. Right. No, it's 0. Right. Okay. How do one increase the accuracy of this estimate? Right. Hey. Right. Otherwise, we're not going to break. Yeah. Okay. No, we. Increase the number of. Okay. So you increase the number of vectors. Alright, can we go to the next one? What time is your match? Hey, right, okay. Where are you playing? No, we're not having triple or switch. No. No, right. Example 2, get going, please. Please, please. Thank you for being a good student today. Okay. I didn't say you wouldn't. I'm allowed to compliment you.
You rejected the chip and dip.
Well,
We want
shall I? Right, okay. Why is it?
to.
I can never see you in any energy or anything slotty, but when it comes to food or coffee, it's like you are a razor beast. Okay. Right, go to example 2. No, it's not. Right, so now it says, okay, we want a lower sum approximation, which is going to also be called a left sum or a left point approximation. Previous question was an upper sum investigation. Okay, so now the same function. Well, bless. Okay, right. F of x is equal to x squared plus 2. Don't worry, you're not going to die. Okay, you remember, you can go to fire and walk out of it. Okay.
Yeah, give it a try.
Okay, right. Sorry? Have I started marking? No, we're marking this weekend.
Oh my God.
It's starting and finishing this. I don't come back with your name in your mark, guys. Right, all right, fine. Okay. So now, okay, just to be the diagram needs to be accurate. Oh, excited. Right, okay. Oh, and by the way, remember that question, Emma, which caused you much stress? In the hypothesis when we were practicing. That's from the last November exam, the hypothesis testing. And we got confused. Okay. As I thought, but then I looked at the memo, I thought, well, I must be wrong, the memo can't be wrong. Dr. Ricky agrees that the memo actually in that question, please don't spread this around, in my opinion, and in his opinion, is wrong. That the way they interpreted the memo is not actually what the question was asking. That hypothesis testing one is when you wrote in October, November last year, where the reading was so confusing.
Oh, yes, you mentioned that on.
Yes, yeah, that was actually terrible. And when I was marking that, I argued with the people that this is not, and I thought, well, I'm not doing. And I realized, I actually, for the record, I am amazing. That's really what I want you to get out of this conversation. Put your hand down, right? Okay. I am actually Einstein's dad. Right, okay, right. F of x is x squared plus 2. Okay. So now we're going to have 4 rectangles, but be careful. The rectangles are going to be left approximations. So your first rectangle would be there. Your next rectangle would be there. Your next rectangle would be there. And your next rectangle would be there. So it's where the curve hits it on its left boundary. So there, and there are your points of intersection with the curve.
Oh, hell no. Yeah.
Why? Different from the previous one. It's a left sum approximation. We did, I know that will happen. And that's how you learn. Growth mindset. Right, okay. Right, so now, by looking at this, Zoe, by the way, just so you know, as men, we are not just objects. Okay. I know you. Right, everyone. Okay, all right. When you go to gym, speak about your behavior in the gym. Yeah, you can't go there and just go there to look at people gymming.
I know.
You have to tell me.
Oh, yeah, but that's just a hard one. You told me.
Okay. So, I was saying that we are not just objects. Okay, so is it going to be an overestimation or an underestimation? No. All right. Okay, so go find the area. On your mark, get set, go. If I beat you, no break. So the x coordinates here are 0, 1, 2, and 3, even though they're 4 rectangles. Okay, so this point will be 3 something. This point will be 2 something. This point will be 1 something. And this point will be 0 something. We've actually said, oh, this is.
No.
Okay.
No, no. I see. Never, I don't think I've ever had a subject. Mathematical induction.
Oh, I love it. Everything's so nice. Right, okay. So, right. Amarilla, what will this be? 3 what? That's fine, we get 3 and 11. So the exponent here is 3 is lies on the curve. So 3 squared plus 2. So, no. So Boris, what's this one going to be? 2 what? Sub it into this. 2 squared is 4 plus 2 is 6. So that's 2, 6. Emma, what's the next one going to be? 1 what? 3. 1, 3, right? And no 2. Are we happy with that? And we have put it away. Right. So area is going to be what, Steve and Eva? This rectangle, what will this area be? 1 times 2, which is this area. It will be 1 times, no. Okay. Yeah, this one will be 2 times 6, which is 12.
What would be 0? Oh, no, 1 times 2. No,
So which is 1?
no, 1 times 6 is 1 times 6.
Okay, so the first one will be 1 times 2, which is 2. The next one will be 1 times 3, which is 3. The next one will be 1 times 6, which is 6. And the next one will be 1 times 11, which is 22 units squared. Quickly, huh? Yeah, we're going to do it quickly. Right. So what is that an overestimation? An underestimation, that yellow bit. Okay. Yes. Sorry, Rosemary. Too far. Right. Okay. So the underestimation. That's how it is. Right. Okay. T refer to yellow area.
Just under.
Right. Next one. Have we done the actual area we did in the previous question? What? Never. Right. Okay. What was the actual area we did in the previous time? Yeah. Yes, it should have been. Thank you. So this area as well. That's also that area. Thank you. Right. Okay. What was the actual area for the previous question? 29,302. Right. Go to the next one quickly. But I'm sorry if I'm minutes. Hey. Basically, we cannot have a break unless you go 6 minutes early. No. 6. 6:45, I stop there, no more. And if you ask again, I don't even give you that. Okay. Right. Quickly. a bit weird, I think. So, you'll get it with that scenario.
What?
So it's not a rectangle at all. It's nothing. The area of that is nothing because you're using a right sum approximation, right? Okay. So on the right side of this rectangle would be that. If I use the right side of the rectangle, that'd be that. That'd be that. This one would be on the right side, which is on the x-axis, right? So there are actually only 3 rectangles that account. We're going to add up the red. Guys, when I'm talking people, I'm going to add up the red, the green, and the blue. Okay. Because this right boundary is on the x-axis. Do you agree with me? So there's no rectangle there. So what do we have to do if it's a right upper sum curve? You have to go to the rectangle. The right boundary must be on the function. So if there's 4 rectangles, okay, you'll have 1, 2, 3, 4. There's the right boundary. There's the right boundary. There's the right boundary. But over here, the right boundary is 0. So there is no because it's on the right side of the function.
Why couldn't you just go up there?
Because I'm looking at this as my base. If that's my base, and my height comes from where the curve intersects with the right side, then this point is over there. And there is no height. So the area of that fourth rectangle is 0. So this x coordinate is -1, that's north, that's 1. But the width cannot be negative, it's the area. The right side of the curve, that's what an upper sum estimation is. Where the right, if you got to draw a rectangle, it's on the note page, then it's where the right side of the rectangle intersects with the curve. You're going to take that as your height. In this case, the right side is on the x-axis, so there's no height to it. Okay. So this point over here would be -1 and 3. This point would be 0 and 4. This point would be 1 and 3 again. Okay, I actually know what this is going to be. If it's an overestimation or underestimation. So if I ask this question, what I'd actually do, I'd work backwards. And I'd say for C, I think it's going to be an underestimation because this area over here, the yellow bit is large, which you've left out. Okay, so that's underestimation. The yellow is the underestimation, and the brown is overestimation. So it looks like the area of the underestimation, the yellow area is bigger than the brown area. So I would think it's going to be an underestimation. So it looks like to me underestimation. Is it? Looks like Because the yellow is the underestimated part, brown is over, and yellow is bigger than brown. So that's why I said it's under. That'll be my guess. How would I find the actual area? The integral between what? Of what function? X squared plus over 3x. Right, is 10,67 units squared, which is confirms that it was, our guess was less than reality. Okay, so our estimation was underestimated. Okay. Start with it when, yeah, good, not bad. Okay, right. Same question answer for this. More rectangles, give us more rectangles. Last one, go. No, next one, sorry. No, next one. What's a left, another word for left thumb? Yeah. Yeah. Four is just my random number, I think. Okay. That's good. Three. There's one person going to jail. No, it's not anyone. All of you. When you use the word mental torture, we will continue with our mental torture of you.
You've given me mental insanity, I will not. Yeah.
I think the lawyers are going to know what then. So, what?
Yeah, I can tweet. I know. We wait 30 times. Yeah.
Get that. This rectangle could now height. This one's got a height of 7. So the area is 1 times 7. What's 1 times 7? Say, out. This area here is 1 times 12, which is by 12, right? This area is 1 times 16, which is 60, not 15, what I'm on. Sorry. So you should get 35. Yeah, it's 15. Yeah, that height is 15, which is 34, right? Okay, what do you think? Overestimation, underestimation? Well, under is there in yellow. There's yellow, under. Definitely under. Is this what you're gonna do the whole time? Trying to get me to say the word underwear. Actual area required. Emma, how are you gonna work out the actual area? But what am I going to put in there? Okay. Okay. What do we take on? It's a big area, but you can see it's a big area from the diagram. Okay. Not rectangle. Uh-uh. Uh-uh. Right. Okay, I'm going to explain it. You're going to be quiet. I'm going to say the next thing is quite quick. And, right. This is serious face, man. Right, okay. Okay. And I will stop talking until you're quiet, and then we'll start again. And if that means we go to 5 o'clock lunch, Bobby boy, then we do. Right. I'm calling you a boy, by the way. I'm just rhymes with Bobby. Right? Oh, I'm going to call you guys. Right. Right. I need to concentrate, and you need to concentrate. If you're not interested, just keep quiet instead. Okay, right. Okay. Explanation of the Riemann sum. Now, this, what we're doing now is really what it's all about. Right, okay, so, how the hell, you get given this on the formula sheet. You have to understand what each of these bits means. Away. I have a minute's credit for Officer Bell. Right, so now, you may open your mouth as wide as you like, it's not going to change. Right, okay. So now, in this scenario over here, we've got a curve, right? And we're trying to find the area under the curve. Okay, so you're going to need to draw a diagram, and we're going to be using this whole page to explain it. Okay. All right. So, yeah, if you don't understand this, you're not going to understand this section. So we have a curve. I'd like to see some lots of appreciation. Maybe a couple of oohs and ahs. That's the only thing you're allowed to say. I told you. Right, okay. So now we're looking for the area under some function f. Okay, so we've got a function, whatever it may look like. Okay, between A and B. And I want the area bounded by the x-axis, those boundaries. Capish? So I'm looking for this yellow area over here. Okay, right. Yes. Ooh, and R. No, right. That doesn't end. Right, okay. Over here, if we take now, we're going to divide this up into, we're going to do a right sum of the area. So, we're just doing a random amount. Yeah, it's just a random amount, we're not going to count it. Right sum, so use the right boundary of the rectangle. Okay. So the Riemann sum is a right, the Riemann sum is a right sum. Okay. So I've got all of these rectangles over here. Okay. Right, and we're going to say that we've got n rectangles. So you know, I mean, like, because they're going to end up being infinite number of rectangles. Only who's an answer. Right, okay. That would be, in that case, that would be. Right, okay. So, let's see. X0, X2. Okay, right. So now, end of the lesson. Okay, trust me, it's hard getting you that twice. See you later. Right. This is going to be some random value x r. I'm just sticking it in. That's no reason. Right. Okay. So I've got n rectangles. A is the first boundary. N is the last boundary. Finish. Okay. So this is, in my case, that's rectangle 1, rectangle 2. So this is xn. That's xi. X0, the first one. That's the x0. This will be x1, x2. You with me? X3. The last one will be xn. Xi is the random variable, so somewhere in the middle of where. Okay, the general expression for it. Okay, so I'm going to pull it just stick to xi with that one. Okay. Right. Now, the objective is I want to get an accurate estimation of that yellow area. In fact, it's going to be exact. Okay, because math is available. Right. So now, okay, we have to figure out this formula. So first of all, okay, what are we going to do to find the area? The principle that we're going to use, I'm going to have things on the side, but basically, we're going to say that the area is going to be equal to the sum of the rectangles. Do you agree with that? The area is going to be the sum of all the rectangles. Do you agree? In this case, I've got n rectangles. The area will be the sum of the n rectangles. Capish? Wait, we'll get right. So, go to the side of the space and let's do a random rectangle. So say I look at this one, which has a right boundary of xi. Okay? Right, so that was xi over there. Okay, so I'm taking this, just this one rectangle, and I'm enlarging it to there. Yes. Okay. This right boundary is xi, right? Okay. Now, this point over here is this point over here. If this is function f, and that's xi, what's the coordinates of this point over here? In terms of I and x and x. The x coordinate would be xi. What would be the y coordinate be? This has been very impressive. Your awakeness levels have been spectacular. Well done. All right. So that's xi, f of xi. That's complete. Right. So that's xi, f of xi, right? So what is going to be the height of one rectangle? You concur. You don't have, when I say you concur, right, okay, good. Right. What is the width of one rectangle in terms of A, B, and N? Well, let's think about this. No, okay, let's say this is, don't write this in, but if this was 20 over here, this was 20, and that was 2, okay? Okay, and there were n rectangles, right? The width of each one would be 20 minus 2 divided by the number of rectangles, every. But this is going to be referred to as A, that's the lower boundary, that's going to be B, right? So the width of each rectangle will be equal to B minus A over N. Does that make sense? You've got N rectangles. So I had five rectangles, Rosemary, and I wanted the width of each one. I'd go 20 minus 2, which is 18, divided by 5. But in general, it's going to be B minus A divided by the number of rectangles that I have. Total width of an individual one. Individual of one rectangle. That's the width of one rectangle. See. Okay. So what's the area of one rectangle going to be? Well, it's length times breadth, right? Or breadth times height, which is going to be what? B minus A over N. What's the height? F of X. You happy with that? Of one, the area of one rectangle. Okay, so the area of that black rectangle in this case, but xi can change. So it could be x1, x2, x3, x4, and vertical. Okay. So the area is going to be equal to the sum of the rectangles. I'm going back here. Okay. So how do I write a sum mathematically? Sigma. Okay. What changes? I changes. This is x1, x2, x3, x4, x5, right? So it's the sum that, and the first height I have is f of x1, right? So from I is equal to 1. And the last height would be over here. This would be the point xn, f of xn, right? So the last number we're going to sub in is n. So the sum of all the areas, let's just say sum of areas of n rectangles. And the area of one rectangle is going to be that, right? So it will be the sum of b minus a over n times f of xi, which is what it says on your formulation. Okay, I'm getting there now. Okay, not quite there, sorry, thank you. Okay, but now, so that's the sum, that's an expression for the sum of all the rectangles. So agree with that. That'll give me the area of the rectangle above n rectangles. But now, to be accurate, the estimation. Okay, what I want to do to the number of rectangles that I have. Make it infinite, right? Okay, so how do we write that mathematically? So your area will be equal to the limit as n tends to infinity of the sum from I is equal to 1 to n of b minus a over n f of xi. Now, because there are no i's in that over there, I can remove a constant from a sigma notation, right? So in other words, if I have the sum of 2x from x is 1 to x is 7, whatever, it would be the same thing as 2 times the sum x is equal to 1 from 7 of x. Just times each term by 2, right? So here, what I can do now, okay, I'm going to have to go one minute over. Okay, it's going to be equal to the limit at n tends to infinity I'm going to take out the b minus a over n, and I'm going to get the sum from I is equal to 1 to n of f of xi. So in this formula over here, okay, this means what? I need lots of rectangles. This means, this represents what? The width of each rectangle. That just means go, add them up. What does that represent? The height of each rectangle. Okay? So now we're nearly done. Okay. No, not quite. Okay? Just give me a second. The problem becomes this f of xi. Okay, so put a little asterisk here. Okay, and go find some space. Now, okay, we have to express xi in terms of a and b, a and n. How could I do that? Well, if I look at this, sorry guys, give me a second. X1 is over there, right? You happy that that's X1? X1, to get to the point X1, where did I start at? I started A, and I go plus 1 width of a rectangle. You agree? Give me 1 second, 1 second. Okay? And what's 1 width of a rectangle? It's A plus 1 width of a rectangle would be B minus A over N. Remember we talked about that just now. That's the width. X1 would be A plus 1. To get to this X1, you could start at A and add a width. Okay? To get to X2, you could start at A and add how many widths would you have to add to get to X2? It would be A plus 2 widths, right? Which is going to be A plus 2 B minus A over N. So in general, what we're looking for a pattern, to get to some rectangle Xi, okay, what would it be equal to? A plus I lots of B minus A over N, right? So then in this formula, f of xi but xi is that, right? But f of xi will be a plus I b minus a over n. In other words, this is what they give you on the formula sheet, but what you're going to have to know is this part over here. So in other words, the total area, which is 30 seconds, will be the limit as n tends to infinity of b minus a over n. What you've got to remember though is that f of xi is a plus I lots of b minus a over n. I have to admit, I mean, on the whole, you guys, I mean, you're paying the NAS generally speaking, but you do have the ability, which makes fairly decent class in the end, that when you have to be quiet, you can. Number, yes.
Is the y coordinate.
Yes. So what they're saying is that xi, to get to xi, you have to describe getting to xi like that, right? So this is just the x coordinate. So the y coordinate is f applies to that.
So it's FR.
I should have been, sorry, thank you. It's equal to, no, that should have been f, and that should have been f. Oh, a plus I b. Thank you. That's important. Put that f in. Okay. So this is xi. Thank you. Got in there. Okay. 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 I feel that's pretty amazing. Well done, me. Right. Okay. Have a good day. Okay.
Triple or nothing.
I think we should try to a whole week to see if we can communicate with who are and maybe I have as well. Huh? Oh, they done it, sorry. I have to. Well, you done it first.
I don't know. The junior school having.
No.
No, the junior school had.
Okay, we have done it. Yo. All right, have a good day, guys. Bye. Home time. When it makes a huge difference, eh? One. Feels like you've had half a day. Bye, guys. Thank you very much.